Ever wondered how distributed systems like Dynamo keep accepting writes, even when part of the system is down? The answer lies in a clever trick called Sloppy Quorum. Here's how it works. In a typical distributed database, data is replicated across n nodes. For a write to be considered successful, it needs to be acknowledged by at least w nodes. But what happens when some of those nodes are down or unreachable? That's where Sloppy Quorum steps in. Let's say you want to write data, but one of the intended replica nodes is temporarily offline. Instead of rejecting the write or waiting endlessly, the system writes that data to a healthy node outside the preferred replica set. This temporary storage is what we call a sloppy write. So imagine replica A and replica B are supposed to handle your data, but replica B is down. The system writes to replica A as usual, and then reroutes the second write to node D, which isn't normally responsible for that data. That's sloppy quorum in action. It prioritizes availability over perfect replica alignment. But the story doesn't end there. Once replica B comes back online, node D performs a hinted handoff, forwarding the stored data back to its rightful owner. This ensures the system eventually becomes consistent again. Sloppy quorum is a brilliant way to make distributed systems more resilient and available, even under failure or network partitions. It embraces the AP side of the CAP theorem, meaning it sacrifices some consistency in the short term, but never stops serving the user. So next time you wonder how massive systems like Amazon Dynamo keep running without skipping a beat, remember, it's a little sloppy, but in a very smart way.